to move us along, let's now rewrite the right side with, in this case, product of sum. All right, so the specific product of sum we're going to use this time, it's the product of two signs. It was sine A, sine B, because it was sine n pi over L x, sine n star pi over L x. Those are the two signs that we have. So that's equal to 1/2 cosine, it's A minus B minus A plus B. A minus B minus cosine A plus B. Sorry. There you go. Cosine A minus B minus cosine A plus B. Always look them up. So we're going to rewrite the right side. So let's see, the right side had the integral and the sum, and the order of those don't matter. We can integrate each term one at a time and do an infinite number of integrals, or we can integrate the thing and then sum it up. Doesn't matter, so I'm going to put the integral on the inside. So it's going to be equal to the sum of n equals 1 to infinity. The an doesn't really matter. That's just amplitudes. They aren't affected by the integral, so they have a value that depends on the Fourier series. So I'm going to pull out the an, and I'm going to pull out the 1/2 out of the integral. Remember, we're integrating with respect to x, so those are just constants. And now we integrate from 0 to L, just like we were told. And instead of sine n pi over Lx, sine n star pi over Lx, we're going to go with this part. So we've already used the half, that's already come out. So we just have cosine of something. So the cosine, it's A minus B, so it's n pi over Lx minus n star pi over Lx. So we're going to write it this way, n minus n star pi over Lx. Right? That's the cosine A minus B term. And then minus the cosine A plus B term is then the same thing, just n plus n star pi over Lx. And one of those, and dx. Okay. So product of sum rule, that's all we did. And now let's integrate. It looks ugly, but it's actually just simple cosine integrals. It's really all it is. So this is still equal to the sum of n equals 1 to infinity a n's over 2. And let's see, the thing we're left with when we integrate. Well, let's see, the integral of cosine is going to go to sine, and we just have to divide by everything in front of the x there when we take that derivative. And it's going to be L over n minus n star pi. Like that, and it's going to become sine of the same thing, n minus n star pi over Lx. There we go. And then minus, and this cosine also becomes a sine, and it's L over n plus n star pi sine n plus n star pi over Lx. And it's that whole thing evaluated from 0 to L. And I think I got all that right. So that whole thing evaluated from 0 to L we'll do next.